The universe is vast and filled with mysteries, from the largest galaxies to the tiniest particles. But what if I told you that the key to understanding everything, how stars form, why the sun shines, and even how we exist, lies in the bizarre and fascinating world of quantum mechanics? Quantum mechanics is the branch of physics that explains how the smallest building blocks of the universe behave. It's a field so strange that even Einstein called it spooky. But despite its oddities, quantum mechanics is fundamental to shaping the universe as we know it. Welcome to Großdenken, everyone. In this video, we'll explore how quantum mechanics governs the universe, from the behavior of atoms to the formation of stars, and even the structure of reality itself. Please support this channel by subscribing. That would mean a great help. So what is quantum mechanics? At its core, it's the science of the very small. It explains how particles like electrons, protons, and photons behave. Unlike the predictable rules of classical physics, quantum mechanics operates on probabilities and uncertainties. For example, in the quantum world, particles can exist in two places at once, a phenomenon called superposition. Particles behave like both waves and particles, depending on how they're observed. This is known as wave-particle duality. You can't know everything about a particle at the same time. The more precisely you know a particle's position, the less you can know about its momentum. This is called the Heisenberg uncertainty principle. These principles sound strange, but they've been proven in countless experiments, and while they apply to tiny particles, their effects ripple out to influence the entire universe. Let's start small, at the atomic level. Quantum mechanics is responsible for the structure of atoms, which make up everything in the universe. In classical physics, electrons would orbit the nucleus like planets orbit the sun. But quantum mechanics tells us that electrons exist in clouds of probability around the nucleus. These clouds determine the shape of atoms and how they bond to form molecules. Without quantum mechanics, chemistry as we know it wouldn't exist. Quantum mechanics also allows particles to do the impossible, like passing through barriers they shouldn't be able to cross. This is known as quantum tunneling, and it's essential for nuclear fusion, the process that powers stars like our sun. Without quantum tunneling, the sun wouldn't shine and life on Earth wouldn't exist. Quantum mechanics played a critical role in the birth of the universe itself. At the moment of the Big Bang, the universe was incredibly small, smaller than an atom. In this quantum-sized universe, particles behaved according to the laws of quantum mechanics. One important concept here is quantum fluctuations. These are tiny changes in energy that occurred randomly in the early universe. These fluctuations were amplified as the universe expanded, eventually forming the seeds of galaxies, stars, and planets. Even today, we can see evidence of these quantum fluctuations in the cosmic microwave background radiation, which is essentially the faint afterglow of the Big Bang. So, without quantum mechanics, the universe as we know it wouldn't exist. So, quantum mechanics also governs how energy and light work. The most basic particle of light, called the photon, is actually a quantum object. Now here's something really fascinating. Photons show both wave-like and particle-like behavior, a concept known as wave-particle duality. This duality helps explain things like the bending of light, diffraction patterns, and even how photosynthesis happens in plants. When it comes to quantum energy levels, quantum mechanics explains why atoms emit or absorb light at only specific wavelengths. That's actually the foundation of spectroscopy, which is how astronomers study distant stars and galaxies just by analyzing their light. On a more practical level, quantum mechanics powers technologies like solar panels, which convert photons into electricity. Honestly, it's no exaggeration to say that quantum mechanics fuels the energy of life and the technology of the future. But quantum mechanics doesn't just shape matter and energy. It really challenges our understanding of reality itself. Take the famous double-slit experiment, for example. This experiment showed that particles like electrons behave differently when they're being observed. When not observed, they act like waves spreading out across all possibilities. But the moment you measure them, they collapse into a specific location. This raises some pretty profound questions about the role of the observer in shaping reality. And then there's quantum entanglement, which is another mind-bending concept. When two particles become entangled, their states are linked, even if they're light years apart. If you change one particle, the other instantly responds. Einstein actually called this spooky action at a distance, and it's been confirmed in experiments. It's also the basis for emerging technologies like quantum computing and quantum communication. So, these phenomena suggest that reality at the quantum level is way stranger than we can imagine, and it might even be interconnected in ways we don't fully understand. Quantum mechanics isn't just a theoretical science. It's actually the backbone of much of our modern technology. For example, semiconductors are used in your smartphone, your laptop, and almost all electronic devices, and they're built using quantum principles. Quantum computing is another area where quantum mechanics really shines. Unlike classical computers, which use bits, quantum computers use qubits that can exist in multiple states at the same time. This lets them solve problems that would take classical computers millions of years. And let's not forget about medical imaging. Technologies like MRI machines rely on quantum principles to create detailed images of the human body. So, quantum mechanics isn't just shaping the universe, it's shaping our daily lives too. Quantum mechanics is more than just a set of strange rules for tiny particles. It's honestly the foundation of everything. It shapes the matter we're made of, the stars that light up the night sky, and even the technologies that power our world. While there's still a lot about quantum mechanics that remains mysterious, one thing is clear. It's not just shaping the universe. It's helping us understand it on a deeper level than ever before. Thank you so much for watching. If you enjoyed this video, don't forget to like, subscribe, and comment below with your thoughts on quantum mechanics.